Hello and welcome to a new Let's Study series on Basic Mathematics by Serge Lang, now with a zoomed in camera. We have a foreword. The present book is intended as a text in basic mathematics. As such, it can have multiple use. For a 1-year course in the high schools during the third or fourth year, if possible the third, so that calculus can be taken during the fourth year. For complementary reference in earlier high school grades, elementary algebra and geometry are covered. For a 1-semester course at the college level, to review or to get a firm foundation in the basic mathematics necessary to go ahead in calculus, linear algebra, or other topics. Years ago, the colleges used to give courses in college algebra and other subjects which should have been covered in high school. More recently, such courses have been thought unnecessary. But some experiences I have had show that they are just as necessary as ever. What is happening is that the colleges are getting a wide variety of students from high schools, ranging from exceedingly well-prepared ones who have had a good first course in calculus down to very poorly prepared ones. This latter group includes both adults who return to college after several years' absence in order to improve their technical education and students from the high school who were not adequately taught. This is the reason why some material properly belonging to the high school level must still be offered in the colleges. The topics in this book are covered in such a way as to bring out clearly all the important points which are used afterwards in higher mathematics. I think it is important not to separate arbitrarily in different courses the various topics which involve both algebra and geometry. Analytic geometry and vector geometry should be considered simultaneously, with algebra and plane geometry as natural continuations of these. I think it is much more valuable to go into these topics, especially vector geometry, rather than to go endlessly. Get this keyboard out of the way. Perfect. Oh, professional. Prepared. That thing was ready to take a dive off of the table. Okay, good, we have enough room now. And the mouse out of the way. Okay, where were we? I'll just restart at the start of this paragraph. The topics in this book are covered in such a way as to bring out clearly all the important points which are used afterwards in higher mathematics. I think it is important not to separate arbitrarily in different courses the various topics which involve both algebra and geometry. Analytic geometry and vector geometry should be considered simultaneously with algebra and plane geometry as natural continuations of these. I think it is much more valuable to go into these topics, especially vector geometry, rather than to go endlessly into more and more refined results concerning triangles or trigonometry, involving more and more complicated technique. A minimum of basic techniques must, of course, be acquired, but it is better to extend these techniques by applying them to new situations in which they become. Motivated, especially when the possible topics are as attractive as vector geometry. In fact, for many years, college courses in physics and engineering have faced serious drawbacks in scheduling because they need simultaneously some calculus and also some vector geometry. It is very unfortunate that the most basic operations on vectors are introduced at present only in college. That is very true. Let me halt the auto-focusing. Here we go. Alright, looks good. They should appear at least as early as the second year of high school. I cannot write here a text for elementary geometry, although to some extent, the parts on intuitive geometry almost constitute such a text. But I hope that the present book will provide considerable impetus to lower considerably the level at which vectors are introduced. Within some foreseeable future, the topics covered in this book should in fact be the standard topics for the second year of high school, so that the third and fourth can be devoted to calculus and linear algebra. If only preparatory material for calculus is needed, many portions of this book can be omitted, and attention should be directed to the rules of arithmetic, linear equations in Chapter 2, quadratic equations in Chapter 4, coordinates, the first three sections of Chapter 8, trigonometry, Chapter 11, and some analytic geometry, Chapter 12, a simple discussion of functions in Chapter 13, and induction in Chapter 16, Section 1. The other parts of this book can be omitted. Of course, the more preparation a student has, the more easily he will go through more advanced topics. He or she will go through more advanced topics. More preparation, however, does not mean an accumulation of technical material in which the basic ideas of a subject are completely drowned. I am always disturbed at seeing endless chains of theorems, most of them of no interest, without any stress on the main points. As a result, students do not remember the essential features of the subject. I am fully aware that because of the pruning I have done, many will accuse me of not going deeply enough into some subjects. I am quite ready to confront them on that. Besides, as I prune some technical and inessential parts of one topic, I am able to include the essential parts of another topic which would not otherwise be covered. For instance, what better practice is there with negative numbers than to introduce them at once, coordinates in the plane as a pair of numbers, and then deal with the addition and subtraction of such points. Component-wise, this introduction could be made as early as the 4th grade, using maps as a motivation. One could do roughly what I have done here in Chapter 8, Section 1, Chapter 9, Section 1, and the beginning of Chapter 9, Section 2. Addition of pairs of numbers and interpretation in terms of a parallelogram. At such a level, one can then leave it at that. The same remark applies to the study of this book. The above-mentioned sections can be covered very early, at the same time that you study numbers. And the operations with numbers. They give a very nice geometric flavor to a slightly dry algebraic theory. Generally speaking, I hope to induce teachers to leave well enough alone and to avoid torturing a topic to death. It is easier to advance in one topic by going ahead with the more elementary parts of another topic, where the first one is applied. The brain much prefers to work in that way, rather than to concentrate on ugly technical formulas which are obviously unrelated to anything except artificial drilling. Of course, some root drilling is necessary. The problem is how to strike a balance. Do not regard some lists of exercises as too short. Rather, realize that practice for some notion may come again later in conjunction with another notion. Thus, practice with square roots comes not only in the section where they are defined, but also later when the notion of distance between points is discussed, and then in a context where it is more interesting to deal with them. The same principle applies throughout the book. The interlude on logic and mathematical expression can be read also as introduction to the book. Because of various examples I put there, and because we are already going through a foreword, I have chosen to place it physically somewhere later. Take a look at it now. Go back to it whenever you feel the need for such general discussions. Mainly, I would like to make you feel more relaxed in your contact with mathematics than is usually the case. I want to stimulate thought and do away with the general uptight feelings which people often have about math. If, for instance, you feel that any chapter gets too involved for you, then skip that part until you feel the need for it, and look at another part of the book. In many cases, you don't necessarily need an earlier part to understand a later one. In most cases, the important thing is to have understood the basic concepts and definitions to be at ease with the simpler computational aspects of these concepts, and then to go ahead with a more advanced topic. This advice also applies to the book as a whole. If you find that there is not enough material in this book to occupy you for a whole year, then start studying calculus or possibly linear algebra. The book deals with mathematics on both the manipulative or computational level and the theoretical level. You must realize that a mastery of mathematics involves both levels. Although your tastes may direct you more strongly to one or the other or both, here again you may wish to vary the emphasis which you place on them, according to your needs or the taste, or your taste. Be warned that deficiency at either level can ultimately hinder you in your work. Independently of need, however, it should be a source of pleasure to understand why a mathematical result is true, i.e., to understand its proof, as well as to understand how to use the result in concrete circumstances. Try to rely on yourself and try to develop a trust in your own judgment. There is no right way to do things. Tastes differ, and this book is not meant to suppress yours. It is meant to propose some basic mathematical topics according to my taste. If I am successful, you will agree with my taste, or you will have developed your own. That completes the foreword. Now move on to the contents. We have part 1 on algebra. We have chapter 1 covering numbers with the sections covering the integers, rules for addition, rules for multiplication, even and odd integers with divisibility, rational numbers, and finally multiplicative inverses. We then have chapter 2 on linear equations with equations in 2 unknowns and equations in 3 unknowns. We have chapter 3 on real numbers with sections on addition and multiplication, real numbers and positivity, powers and roots, and inequalities. We then have chapter 4 on quadratic equations. We have an interlude on logic and mathematical expressions, on sections on reading books, on logic, on sets and elements, and notation. We move on to part 2 on intuitive geometry with chapter 5 covering distance and angles with sections on distance, angles, and the Pythagoras theorem. With chapter 6 on isometries with sections on some standard mappings of the plane, isometries, composition of isometries, inverse of asymmetries, characterization of asymmetries, and congruencies. We have chapter 7 on area and applications with the area of a disk of radius r and the circumference of a circle of radius r. Then have part 3 on coordinate geometry with chapter 8 coordinates and geometry with sections on coordinate systems, distance between points, equation of a circle, rational points on a circle. We have on chapter 9 operations on points with sections on dilations and reflections, addition, subtraction, and the parallelogram law. Chapter 10 covers segments, rays, and lines, with segments, rays, lines, and the ordinary equation for line sections. We then have chapter 11 covering trigonometry with sections on radian measure, sine and cosine, the graphs, the tangent, addition formulas, and finally rotations. We have chapter 12 on some analytic geometry with sections the straight line again, the parabola, the ellipse, the hyperbola, and rotation of hyperbolas. Finally, we have part 4 on miscellaneous topics with chapter 13 covering functions with the definition of a function, polynomial functions, graphs of functions, exponential function, and finally logarithms. We have chapter 14 on mappings with a definition, a formalism of mappings, and finally permutations. Chapter 15 covers complex numbers with sections on the complex plane and the polar form. We have chapter 16 and we have chapter 16 induction and summations with induction, summations, and geometric series covered. In chapter 17, we have determinants with the sections on matrices, determinants of order 2, properties of 2 by 2 determinants, determinants of order 3, properties of 3 by 3 determinants, and finally Kramer's rule, or Kramer's rule. Kramer or Kramer, not sure. And then finally we have the index. That completes the contents, as well the foreword and contents of Basic Mathematics by Serge Lang. Next video, we will be covering Chapter 1, Section 1. Thank you for watching.